on smart architectural programming, and in this video we'll be focusing on another LeetCode Blind 75 list of problems. These problems are the most commonly appearing in coding interview. Before we start though, I would like may pop up request you to coding please like and subscribe our channel, and if you got any value out of it, and if you want a specific issue to be addressed, please let us know in the comments below so we can create a video about that issue as well. So without further ado, let's dive into our Blind 75 problem for today, which is serialize and deserialize binary tree. Now, this is the last of the binary tree related problems in the Blind 75 list of questions, and this problem is quite simple, to be honest. Let me just let me get things sorted out for that. So given that we have this tree, so I need to explain this so that we can get an understanding about this particular problem. So given that we have a binary tree like this, right? Let's pull it up a little bit. We have this binary tree. So given this binary tree, let me actually add a couple more things on this binary tree before we move forward. And let me change the color here. That's black. So this is, let me use a different sized color. Yeah, here it is. So we have further extensions on both these sides, and these are null values. You'll understand in a minute why I'm adding null pointers at the end of these binary trees, but before that, let me just add those values up. So basically, first you need to understand how we serialize a binary tree. So serialization, in simple terms, it's not something that's very technical. It simply means that you convert this binary tree, this graphical representation of the binary tree, into a value that is easy to move around, basically within your coding environment, right? So if we want to serialize this problem, serialization would look something like this. First, we'll have a 1, which is the root node here, right? So we get this done. Then, before that, quick reminder: we're using depth first search because it's cleaner, and you need to write less lines of code using this mechanism. And within that, we're going to use the in or pre-order traversal. I think that we discussed in the previous problem, which is basically how you navigate through binary trees. So we're going to use these two things. We're going to use depth first search, and we're going to use pre-order traversal, right? So in pre-order traversal, if you didn't watch the video previously, I'll just go over a little bit about that as well. Pre-order traversal works like this. You start at the root node, right? Like this is one here. Then you go to the left branch, cover the left node, right? And then you cover, if you have another option, you go left again. So with pre-order traversal, first you sort out all values to the left side, right? So once we're done with this left side, right, then realize we come back to this node. Then we handle the right side, right? And then we come back here, and then we handle right side as well, so on and so forth. And that's basically how pre-order traversal works. But generally speaking, you need to remember this simple rule for pre-order traversal: root, left, right. If you follow that rule, you'll never go wrong with pre-order traversals. So coming back to the question and coming back to the serialization part, so we have added 1 in our serialization. Then we go to the left, as we're using pre-order traversal. We find 2 over here, and 2 goes next, right? Similarly, then we go left again, and we find some, but there's no value on the left, right? But we still enter the value of null. We write the complete null, but I'm just writing n, so I could be more shorthand about these values. So we go and write n here, right? So that is why we're adding null values at the end of nodes that have no further nodes attached to them, so that we can represent that in the binary tree representation. because when we transfer this over in the deserialization part, we need to rebuild this binary tree using the serialization. So for that we need some markers, and these markers tell us where the binary tree ends, right? Similarly, then we go to the right, there's another n, so we write that n here as well. Then we go back to the top one and we move to the right side now. On the right side we come to number 3, right? So we add 3 here. But we now move back to the left side because now we have values to the left that are available. So we can't move to the right until we handle all the values to the left based on the pre-order traversal rules that we need to follow. So let's move this to the left side and we write 4 here now. So 4 comes here next. Then we look at the left side of 4, which is a null value, and the right side, it is also a null value. So I'll just add 2 n's here so we can quickly move along on the serialization part that we're doing. So let's write n here as well. And now we have done this 4, covered both left and right sides of the 4 node. Go back to 3, left side is covered. We move to the right side, which is 5. Right, we add 5 here, and 5 also has 2 null values next to it, so we write those 2 values as well. So this is what serialization looks like, and this is what you need to do on serialization, simply speaking. It's just the only difference between the previous problem and this problem is that in the pre-order traversal you also need to note down that where the tree and node ends by noting down null values next to those values basically. So now that we've done serialization, you also need to do deserialization. So basically, ultimately in this question, you first serialize, the purple arrow shows serialization, and then let's say the blue arrow, the light blue arrow shows you deserialization. And that is what we need to do in this particular problem. And it's very simple to reconstruct the node if you're giving a serialized value. We know 1 comes at the top, right? Then we know we move to left first, so 2 is the next value, right? So we write 2 here. Similarly, we know after 2 that we go left again from 2 then, and there's a null value there, right? So we do that, null comes here, then we go to the right on the 2 side, there's another null, we go right and write null. As you can see, 1, 2, null, null. So it's easy to read exactly how we can build this. Then we know, because there are 2 null values here, then we go back, understand the left node ends there, because all roots on the left node are at null now. So we climb back to the top, we know next 1 is done, so the next value is 3. So we pull back here, write 3 here, and so on and so forth, right? So basically it's very, very simple to do serialization and understand exactly what we mean by serialization and deserialization in this problem. So with that out of the way, let's move towards our coding in question. So basically what you need to understand about our problem here, that we're using depth for we're using pre-order traversal here basically, right, in this problem, and we to do serialization and deserialization. And you can look at the code. Both the time complexity for a serialization and deserialization is O of n, and the space complexity is O of n as well. Based on that, you can see first we encode a tree to a single string. If there's no root node, we return an empty list. Otherwise, we simply run our code basically, and we do the same on the opposite side. Based on that, if we run this code, you'll see that both of our cases have been accepted and properly processed. If we submit this code, it should also work at the same time. So that's how you solve a serialization and deserialization binary tree problem from the blind 75 list of questions. With that, I'm going to sign off and see you on our next video. Thank you.